All right, 4.1, day 3. In this video, you will see the remainder theorem, and you will also see the factor theorem. So, as long as you remember your synthetic division, the remainder and the factor theorem should be pretty simple. So, let's jump into it. Let's get started, see what this is all about. So, the remainder theorem. For right now, I'm going to skip over what it says there. If a polynomial, etc., etc., etc. We'll get back into what that means after we do the example. I think you'll understand that a little bit more. So, if I take a look at letter E, it says use the remainder theorem to find p at -5 for that polynomial function, then verify your answer algebraically. So I want you to think about this. I'm going to show you two ways how to do this. Old school, the way that you've been doing it your entire life, and then new school, the faster, more effective way to do this. So think, old school. To find p at -5, what do you think we could do to figure out what p at -5 is? Well, hopefully, you're saying to yourself, well, I think what I can do is just simply take -5 and plug it in wherever I see an x. Great, fantastic. That's exactly what you did in the past. So if we do that, I get this here. Okay, so I get 625, yada, yada, yada. So our old school way, okay, a little bit longer, but hopefully I have a calculator and I'll be able to do that. And I get positive 19. All right, so that's the way we've been doing it our entire life. But what I want to show you today is that I can work a little bit smarter. I don't want to work harder, I want to work smarter. So in order to work smarter, the new school way, I'm going to use my synthetic division skills. And in using my synthetic division skills, I think what I'm going to use is it asks me to find p at -5. So it's telling me what number it wants me to use. It wants me to use -5, so in my synthetic division I'm going to use -5. I absolutely would write that in my notes. I would make a note of it when it tells me what number to use. That's the number that I should absolutely use in my synthetic division. It tells me to find p at -5, so okay, I'm going to find p at -5 and I'm going to use -5 with my synthetic division. So now, look at your function. Do we have to worry about placing any zeros when we do our synthetic division? Well, you should be saying to yourself, nope, there's no terms missing, so I'm simply going to write the numbers down. There they are. I know to do my synthetic division. Hopefully you're getting better at this. If you want to pause the video from here and try it on your own to see if you get the same thing, then great, fantastic, do that. Here is what your synthetic division should look like. Notice, our old school way, we got positive 19 as the answer. My new school way, look at that. My remainder is my answer. So what do you think? What do you think the remainder theorem is? Oh, look at that. So I know when using the remainder theorem, my answer is going to simply be just the remainder. So think about that. Some things that I would write in my notes. When it gives me a certain number, it's telling me to use -5. So -5 is definitely what I want to use for my synthetic division. When it asks me to find a specific number, aka this p at -5, I know that my answer is simply just going to be the remainder. Okay, so remainder theorem, I wonder why it's called that. Well, your answer is the remainder. That's why it's called that. Okay, let's keep going. The factor theorem. All right, again, I'm going to skip that stuff in the beginning. If x may, okay, let's do 2 examples, 3 examples, and then I think you'll understand what the factor theorem is. So, letter F. It says determine if the following are factors of that polynomial. Notice I gave you a polynomial where no terms were missing. I think this is going to be maybe a little bit difficult to understand, so I figured let's not throw any zeros in there, so when we do our synthetic division, don't have to worry about the zeros. Alright, so to determine if the following are factors, notice the difference. In letter F, now it's giving me x minus 2. When I set up my synthetic division, what number is going to go in the box in the upper left-hand corner? Hopefully, you're noticing the difference. When we did, in the last problem, when we did the remainder theorem, notice how it gave us a specific number. Yesterday, when we did synthetic division, we had to find the zero of that divisor. So hopefully you're understanding the difference, that I should put a positive 2 in that box, because I have to figure out what makes this equal to 0. When it gives me a specific number, that's the number I'm going to use. But when it gives me a factor or a divisor, that's when I have to find the 0 of it. Hopefully you understand the difference between the two of them, and let's keep going from here. At this point, hopefully you are getting really good at synthetic division, because I'm going to kind of start going a little bit faster as we kind of get through these videos. If you are struggling, please, let's ask in class. You know, when we do some homework, I'll give you some extra problems to work on. So let's kind of talk about our synthetic division. Okay, so there are the numbers. Obviously, we know where those come from now. I'm going to assume that you can do your synthetic division from here. Notice that I got a 0 remainder. If I get a 0 remainder, notice, 0 remainder. If I get a 0 remainder, then I know that x minus 2 is a factor. Here's what I want you to think about. Think about some, second grade math. If I did 12 divided by 3, and I said, okay, 12 goes into 3 4 times. When I subtract them, I get a 0 remainder. We said that this positive 3 was a factor of 12 because it went into it evenly. That's kind of important to remember. It kind of went into it evenly, and therefore I know it's a factor of that polynomial, or of that number. So in this one, in letter F, first one, if I get a 0 remainder, that must mean that x minus 2 is a factor of that. Okay, that's not that difficult. So understanding factor theorem, okay, if I get a 0 remainder, then it's got to be a factor. Okay, so understand that. Second one, take a look. I have x plus 1. If I set up my synthetic division, hopefully negative 1 in the box. Set up your synthetic division from there. Hopefully you're able to do the synthetic division. Hopefully you are pausing it and kind of doing it on your own to double check to make sure you got it. Here is what it should look like. Notice that I got a negative 60 as a remainder, so I'm obviously saying x plus 1 is not a factor. Not a factor because I didn't get a 0 remainder. Alright, number 3. Kind of gave you one that's a little bit more challenging. Can you tell me in the third one what makes that 3x minus 2, what makes 3x minus 2 equal to 0? Come on, 3x minus 2, what makes it equal to 0? Hopefully you are saying that 2/3 is what makes it equal to 0. If you're not sure, think about what I did in my head. I did 3x minus 2, and I figured out what made it equal to 0. So I add 2, I divide by 3. There is the 2/3 that I was looking for. Okay, so that's how I got the 2/3. Don't be scared. It's not that difficult. I made sure that it was doable, and obviously you have your calculators. You should do it in your head, but I won't ever know. So think about your synthetic division, set that up. I know I bring down that first term. then I multiply them. I'm going to show you this. I don't care if you want to watch or not. You're going to watch. What I'm thinking in my head without using my stupid calculator, I'm doing 2/3 times 3. I'm going to put 3 over 1. Okay, so in my head, I know this and this are divisible by 3. I know they cancel out, and I get a positive 2. So that's what I'm doing in my head when I do these. So please, it's not that difficult. Understanding that you can multiply them without using your calculator. Let's be big boys and girls right now. We can do this. So when I multiply them, I get 2. When I add them, I get 0. Keep doing that process. Multiply them, add them. This is what you should get. So, obviously, I got a 0 remainder. That tells me that 3x minus 2 is a factor. Okay? So, let's go back up to where it says the factor theorem. Some things that I would probably put in my notes now so you understand those 2 bullets that I have there. First of all, that second bullet was basically what we just did in those 3 problems. If x minus c, let's plug in a number there, like let's say it's the first one. If x minus 2 is a factor of that polynomial, then the remainder is equal to 0. So if you need to translate that into your own words, if x minus c is a factor, then the remainder is 0. The first bullet, I want you to think about this. Think about what I just wrote down for a second. If p of c is equal to 0, then x minus c is a factor of the polynomial. So let's say when I do p of 3, when I plug in 3 for this function, and I get 0 as a remainder, well, I know it's a factor, right? Because it goes into it evenly. It's what we just talked about. So if 3 goes in, if 3 is the 0, then x minus 3 must be the factor. Do you see what I'm doing there? I'm telling you that this is the 0. That must mean the x minus 2 is the factor. Hopefully, you can wrap your brain around that. Look, -1 is the 0. That means that x plus 1 would be the factor. That's obviously if it was a true case. That's not. So let's not talk about that. Ready? Look. If 2/3 is the 0, then 3x minus 2 must be the factor. Hopefully, you got that. Think about this. What if I told you p of 6 equaled 0? What would the factor of that then be? Well, you'd tell me, okay, the factor would then be x minus 6. Hopefully, that's going to help you get through this. Remainder, factor theorem, understand the difference between the two of them, and good job.